In this video, I will discuss a JEE Advanced PYQ from the topic alternating current. First, I'll discuss some basics. For a resistor, when the voltage drop is applied across it, say V volts, the current I will start flowing in it if there is a closed path. If you increase the voltage, the current will increase. That is, current is proportional to the applied voltage. And this constant of proportionality is the resistance value, and this is Ohm's law. So if you draw a table between voltage and the current, say the voltage is say 1 volt, the current is 8.5 amps, assuming the resistor value is say 2 ohms. I equal to V by R, so this divided by 2 is 0.5. So if I increase the voltage to 2, the current will increase to 1, say 10, it will become 5 amps. And if I reverse the direction of the voltage, say minus 1 volts, then the current direction will reverse. So the current will flow in this direction. So that is represented with a negative sign. So instead of applying steady voltage like this, I can also apply a time varying voltage, which varies in form of a sign. So this is 0 level, and I say apply maximum voltage of say 10 volts, and in the other direction minus 10. Even in this case, for a time varying voltage, Ohm's law is valid, and I'll get a current also varying sinusoidally with a maximum of 5 amps for 2 ohm resistor, and in the negative direction also 5 amps. So for time varying voltage also, the Ohm's law is valid. Similarly, if you take a capacitor and apply a sinusoidal voltage, see V across it, here also the current I, which is flowing here, is proportional to the voltage that's appearing across this capacitor. Similar to Ohm's law, for a resistance we can also have Ohm's law for a capacitor, V equal to the current I into the capacitive reactance XC. XC, the capacitive reactance, is 1 by omega C, where C is the capacitance value, and omega is the angular frequency, which is related to the time frequency as 2 pi f. But for a capacitor, the current will lead the voltage by 90 degrees. Here these two will be in phase, in the sense like when this is 0, this will be 0. When this attaining the peak, current will also attain the peak. But in a capacitor, the current will lead. If this is the variation of the current in the capacitor in the voltage waveform, will look like this across the capacitor. So here the voltage is attaining a peak after 90 degrees. This is the same time. Voltage attaining a peak later. The current is attaining a peak earlier. So current is leading the voltage by 90 degrees. This relation between current and voltage we can figure out from this capacitor. For a capacitor we have this relation, Q is C into V, where V is the voltage applied across the capacitor and C is the charge stored in the capacitor plates. Differentiate both the sides with respect to time, dq by dt is the current I equal to C into dV by dt. So if, for example, V varying as sine as a function of time, like sine omega t, then I will vary as cos omega t, because derivative of sine is cos. So here I is varying as cos and voltage as sine. So from this we can figure out that current will lead the voltage in a capacitor. This is for a sinusoidal voltage. Now the basic thing is, for this capacitor, if you apply a DC source, but I'll close the switch at time t equal to 0. Before that there is no voltage. So the same capacitor, say C here, and have a DC source of voltage E, but there is a switch here. Before t equal to 0, the switch is open, so the current is 0. Let me take the initial state, and the switch is closed at time t equal to 0. As soon as the switch is closed, the current will start flowing, and this current, before it reaches a steady state, it will be a time varying current or a transient current. Once it reaches the steady state, the capacitor will get fully charged, and this will act as an open cycle, so the current will reduce to 0. So writing KVL in this loop, voltage across the capacitor, that's VC, this is the RC circuit, there is a resistor also. So voltage across the capacitor plus I into R, I is this current, time varying current, equal to the supply voltage G. And V is I into XC, where XC is 1 by omega C. Sorry. And V is Q equal to C into V. So this is Q by C. For a capacitor, this relation is valid. So from the secondary, the voltage as Q by C, where Q is the time varying charge plus IR, you go to the right hand side. So differentiate this thing with respect to time. dq by dt is the current I plus di by dt into R, and this is a DC source, so differentiate with respect to time, I get 0. So from this I'll get di by I equal to minus RC. This is simple manipulation. Take this term on the right side, bring the current down. Now integrate both the sides from time t equal to 0 plus, that's after the switch is closed, to arbitrary time t, and there will be some initial current to some arbitrary current. So this I'll get as ln I by minus RC into t. So from this I get the current I as the initial current into e to the power minus t by RC. I made some mistake here. It's 1 by RC. I will go here. So this is 1 by RC. So 1 by RC, so it's T by RC. And this initial current, as soon as the switch is closed, the capacitor has got the property, it will act as a short circuit, because whatever current is pushed here, it will absorb the charge, so it's as if there is no resistance to the capacitor. So as soon as the switch is closed, this will act as a short circuit, so the current will determine this resistance, that will be E divided by R. E is known, R is known, so the initial current is known. One more thing is, if this capacitor had got initial charge Q naught, that will say correspond to your voltage of E naught, then the initial current will be E plus E naught, the initial charge, initial voltage across the capacitor by R. With this understanding, we solve the JEE Advanced question. Timestamps are given in the description box. You can watch parts of video if running short of time. This is a question. At time t equal to 0, the terminal A in the circuit shown in the figure is connected to B by a key, and the alternating current IT equal to I naught cos omega t with I naught equal to 1 amp and omega to 500 radian per second starts flowing in it with the initial direction shown in the figure. At t equal to 7 pi by 6 omega, the key is switched from B to D. Now onwards, only A and D are connected. A total charge Q flows from battery to charge the capacitor fully. If C equal to 20 microfarad, R equal to 10 ohms, and the battery is ideal with an EMF of 50 volts, identify the correct statements. Statement A, maximum charge on the capacitor before T equal to 7 pi by 6 is 1 into 10 to the minus 3 coulomb. The current in left part of the circuit just before T equal to 7 pi by 6 omega is clockwise. Statement C, immediately after D is connected to D, the current in R is 10 amps. Option statement D, Q is 10 to 2 into 10 to the minus 3 coulombs. You can pause and learn this question. So this switch is thrown from here to here at T equal to 7 pi by 6 omega. Let me call this time as say T1. So at that instant of this switch is thrown, what is the charge in this capacitor? That we can find from the current here. This current at that time T1 is I naught is 1 into cos omega t. Omega t for this time is 7 pi by 6. So this is the current flowing there. And the voltage across the capacitor it will have a maximum value, that is Vm into whatever is this phase, the voltage will lag by an angle of 90 degrees, which is pi by 2 radians. Current will lead the voltage by pi by 2. So voltage is lagging the current by pi by 2. So I have to subtract this angle by pi by 2. And Vm is related to for a V equal to I into Xc. So Vm equal to, so Im is 1, which is same as I naught. Xc is 1 by omega c. So Vm is 1 by omega c into, so this is cos 6 pi by 2, 7 pi by 6. So this is pi plus pi by 6. So this will be pi by 2 plus pi by 6. This is pi plus pi by 6. So pi and minus pi by 2 will become pi by 2. And then pi by 6 will come here. So this will become sine pi by 6. And this is in second quadrant. So it's negative. So there will be a minus sign. So pi by 6 is 30 degrees. So minus half. This one is minus half. So this is the voltage across this thing at this particular time t1. Because I put this value of time t1, only then I'll get this omega t as 7 pi by 6. So this is the voltage. So the initial charge at this time instant, just before the switch is thrown, that is Q at time t1, is this into C. So it will be 1 by omega into minus half. So omega is 500 radian per second. So 502 is 1000. So minus 1 millicoulomb. So with this thing, so the initial charge will look like this. 1 millicoulomb with this polarity. Okay, so when this switch is thrown here, and after a long time, this capacitor will get fully charged by 50 volts. At infinity, it will have 50 volts here. So that will correspond to a charge of C into V. So 5 into 2 is 10,000, 1 millicoulomb. So after the switch is thrown here, and once the steady state is reached, that's after a long time, the full 50 volts will appear across this with this polarity. So this 50 will correspond to a charge of 50 into 20 micro, that's 1000 micro, which is 1 millicoulomb. So initial charge is minus 1 millicoulomb with this polarity, and final charge is this one. So the total charge that's flown after the switch is thrown is 2 millicoulombs. Statement D, it says 2 millicoulombs, Q is 2 millicoulombs, where Q is the total charge Q that flows from the battery to charge the capacitor fully. So D, statement D is true. Statement A, magnitude of maximum charge, or we can see the magnitude of maximum charge before the, so current is varying as this variation cos omega t. So the switch is thrown at 7 pi by 6. T equal to 0 is here. So initially the current is 1 amp. They are given the current variation as I naught cos omega. So it's basically cos variation I naught cos omega t, and I naught is 1. So initially it's 1 amp. At omega t equal to pi, I plot omega t. And then pi plus pi by 6, because this 7 pi by 6 is up to pi by 6. I have to go up to 7 pi by 6. So this is the variation of current in the circuit. And the voltage variation will appear as sine. So we'll reach a peak here. So this is the voltage variation. Before the switch is thrown, it's just capacitor and a AC source. So charge will also attain a maximum at the same point, because charge variation is same as this one, because Q is nothing but C into V. So this multiplied factor C is this one. So if I know Vm, I know Qm. So Vm is 1 by omega C. So Qm is Vm into the capacitance value. So C will cancel, it's 1 by omega. So 1 by 500. So that is 1000 by 2, 1000 by 500 into milli. So it's 2 millicoulombs. So the maximum charge before that time the switch is thrown is 2 millicoulombs. Maximum charge of the on the capacitor before T equal to T1 is 1 millicoulomb. So option A is not true. B says the current in left part of the circuit before that T1 is clockwise. Just before the switch is thrown, the current is negative. So according to the polarity, the current is negative. So the current is flowing in this direction. So that means the current is flowing anti-clockwise in the left part of the circuit. So option B is false because the current in left part of the circuit before the switch is being thrown is anti-clockwise. They are given as clockwise. Statement C immediately after E is connected to D, the current is 10 amps. So use the property of the capacitor. As soon as the switch is closed, the capacitor acts as a short circuit because what the charge is pushed there, which is accepted. So the current here, as soon as the switch is thrown, is 50 by 10, that is 5 amps. Sorry, there is an initial charge. So just before this thing is, just at the time it's thrown, it has got a charge of 1 millicoulomb. So that will correspond to your potential between these 2 points as 50 volts. Because 1 millicoulomb into 20 on by C, voltage is Q by C. Because Q equal to CV for a capacitor. To get the initial voltage, I just have to do the initial charge by the capacitance value. Initial charge is 1 millicoulomb. So that divided by C, which is 20. So it will be 1 millicoulomb by the capacitance value 20 micro farad. So it will be 1 by 20 into 1000. So it will be 50 volts. So it will be 50 volts with this polarity. So the initial charge will be the total voltage, which is 50 plus 50, 100 by 10, which is 10 amps. So as soon as the switch is thrown, so the current at I equal to T1 plus on the right circuit will be 10 amps, and that will flow through this R. So option C is true. So the correct options are C and D. That is the correct answer. So this would explain here at the time instant where the switch is thrown from one position to other position, that this is that time T equal to 7 pi by 6 omega. The current will be I don't to cos omega t will become 7 pi by 6, that is same as pi plus pi by 6. So this much amps. And the voltage is lagging this current by pi by 2. So this minus pi by 2 is the capacitor voltage. And Vm is Im into Xc. So Im is I0, which is 1, and Xc is 1 by omega c. And this will become sine because pi by 2, and then sine 30. And this is in second quadrant, so it will be cos in second quadrant is negative, so it's minus. So this will be minus 50 volts just before the switch is thrown. And the corresponding charge will be minus 1 millicoulomb. And the charge at infinite time is the capacitor will act as an open circuit, and the entire charge will be, entire voltage will appear across the capacitor. That will correspond to a charge of 1 millicoulomb. So total charge is from minus 1 millicoulomb to plus 1 millicoulomb. So total charge flown is plus 2 millicoulombs. So option D is true. Current when the resistor, when the thing is thrown, is the initial voltage, that the entire voltage in the circuit, that's 50 in the capacitor and 50 in the battery source, it's 100 divided by the resistance value. The capacitor will act as a short circuit as soon as the switch is thrown. That's the property of the capacitor. So that corresponds to 10 amps. So option C is true. Option B, you have to get the maximum charge before the switch is thrown at pi equal to pi plus pi by 6. That is before this one. So that will correspond to the time where the voltage is maximum, because Q is C into V. So whenever V is maximum, Q is also maximum. So if you get V is maximum, that multiplied by C will give me Q maximum. So Q max is C into V max, and this V max is current maximum into XC. This is ohms of a capacitor. So from this I get the maximum charge as 2 into 10 raised minus 6, so 2 millicombs. So option A is false.